So there is a question R. It is from NCERT. P comma Q. Relation R is such that P comma Q. P and Q are the points. Okay. So OP is equals to OQ, where O is origin, P and Q are some points. Okay. And then in a relation R, ordered pair P and Q exist if OP is equals to OQ, means the distance from point O, means from origin to point P, is equals to distance of point Q from origin. Okay, so we have to check whether it is a reflexive, symmetric, or transitive. Okay, so first of all, let's check about reflexive. So consider a point, any point. Let's say P. Now, for any point P. Okay, OP is equals to OP. It is understood. For any general point P, OP is always going to be equals to OP. Okay, so this implies that P comma P belongs to R. It is understood, right? So for any point P, OP is always equals to OP. Okay, so P comma P will belongs to relation when OP is equals to OP. So obviously it is OP equals to OP, so you have to write it like this way. So OP is equals to OP, so this implies that P comma P belongs to R, hence R is reflexive. And the second point is symmetric. So we have to check whether this relation is symmetric or not. Okay, so to do so, let P comma Q belongs to R. So let's say P comma Q belongs to R. Now if P comma Q belongs to R, this implies that OP is equals to OQ, where O is origin and P is any point. Now this can be written as, if I rearrange them, I can write like this: OQ is equals to OP. So if PQ belongs to R, this implies that OP is equals to OQ. Now this can be written as OQ is equals to OP, right? So this implies that now Q comma P belongs to R. Okay, so it is very simple. PQ belongs to R. This implies that OP is equals to OQ, and we can write like this: OQ equals to OP. Now this implies that Q comma P belongs to R. Hence it is symmetric as well. So R is symmetric. Got it? And next is transitive. I have to check whether it is transitive or not. Okay, so what is transitive? So in order to prove that this is transitive, we have to take one more point. Let's say P comma Q belongs to R. Okay, P comma Q belongs to R. So this implies that OP is equals to OQ. And let's say this is equation number 1. Now second point is, let's say Q comma S. Q comma S also belongs to R. So this implies that OQ is equals to OS. Equation number 2. And first and second. Now we have to prove that. Keep it in rough work. We have to prove that. So this by doing this way, it is very simple to solve it further. So what we have to prove? We have to prove that P comma S belongs to R. So this is only possible when OP is equals to OS. So somehow by using equation 1 and 2, you have to prove that OP is equals to OS. Now from first and second, so OP is equals to OQ and OQ equals to OS. So from 1 and 2, by comparing these two, you can say that OP is equals to OS. So it is very easy, right? OP is equals to OQ and OQ is equals to OS. So by using this, you can substitute just OQ value of OQ here, and so OP is equals to OS. So that's it. So this implies that P comma S belongs to R. Hence R is transitive. Very simple. Okay. So if a relation is reflexive, symmetric, and transitive, then you can say that it is equivalence. Hence, so R is equivalence relation. Right. So that's it. This is a rough work. It is just used to frame out how to solve it further. And this is the stepwise how to solve the questions. Okay. Now next question is okay. Just a minute. now, so this is a very important question. A relation R is defined on n cross n. So till now you are solving the questions which are defined on a set, right? So from here now you are going to solve this question, relation R on n cross n. Okay, so basically for before that, all relation R, a relation defined on a set A. A relation is defined on set A, but in this question a relation is defined on the Cartesian product A cross A. So the important thing is, when this type of questions are there, you have to check for an element A, right? Set A will have elements like A, B, C, okay? But in case of relations, in relation means A cross A represents a Cartesian product. So in this A cross A, the element will be like A comma B. This will be an element, okay? So just for illustration purpose, 1, 2, 3, let's say. Now the elements in this set A can be written as 1 or 2 or 3, but in A cross A it could be like this, right? Like something like this. So the elements is going to be in the form of A comma B, like 1 comma 1. That is why you have to keep in mind, in when a relation is related from a set A, the elements are going to be a single element, 1, 2 and 3. And when a relation is defined on the Cartesian product of two sets, the element of the relation, right, and even element of that particular set from which we are retrieving this relation, A cross A, is going to be like A comma B. You're getting my point? So better is we just solve this, and after solving this it is going to be very clear. I will take one more example, or one or two. I will take a lot of example. By that way it is going to be very clear. Okay, so this is what I mean. So let's solve it. So it is saying that A comma B, so as an element, where in the previous questions this element is represented by a single letter like A is related with B, right? A is related to B, okay? But in A comma B is a element of n cross n. So that is why A comma B is related to C comma D if, what do you mean by if? If means if this is a relation, if this is related, then this implies this, and if this relation if this relation is equivalent, means left hand side is equals to right hand side, then you can say that this, okay? So it is something like this. If this expression is A, so A, if A then B, or if B then A, something like this, okay? So we have to prove that whether it is a equivalence relation. So how can you do this? Now first of all, reflexive relation. In starting it could be a bit confusing, but later on I will take some more examples and it is going to be very clear. Okay, so A comma B is related to C comma D. So in reflexive, what we are going to do, so in this relation is defined on n cross n. So in n cross n, the element will be like A comma B, 1 comma 1, 2 comma 2, 3 comma 3, like this. Okay, so I have to take it like this. For all A comma A, sorry, in n cross n, element will be like this, A comma B. For all A comma B belongs to n cross n. Remember that previously we are doing it like this. For all A belongs to n, or set A, right? So here set A is replaced by n cross n. For all A comma A belongs to R, I can write like this. Okay, so we have to prove that A comma B is related to A comma B. I have to prove this, right? A is related to A, means A comma A belongs to R can be written as like this, A is related to A. So that is why A comma B will be like A, and this is also going to be like A. Okay, so A is related to A. I have to prove this. In order to prove this, what I have to write is, so this is basically a rough work. Okay, just to making it understand. So I am going to do it like this. So A comma B is related to A comma B. So what does it mean? So it will be related if A into D, A into B, B plus A is equals to, and in this side BC, and this will be multiplied as BA, and this will be added A plus B. of course they are equal, right? So I can write it like this: for all a comma b belongs to n cross n. Okay, so this is a rough one basically. You please note it down in rough side. I am gonna do it directly. Okay, so for all a comma b belongs to this, I can write it like this: a b, b plus a is equals to b a, like a plus b. Okay, so if this relation holds, if this left hand side is equals to right hand side, then you can say that, and of course they are equal, ab is equals to ba and b plus a is equals to a plus b. So this implies that a comma b is related to a comma b, hence a comma b related to a comma b. Okay, so a is related to a, that is why it is it is reflexive, hence R is reflexive. Don't worry if you are not getting this. In the next question, I will take some other example on this basis, and it is going to be very clear. Okay, so R is reflexive by this way. And next is symmetric. In symmetric, so a comma b. So let a comma b is related to c comma d. So so just for understanding purpose, you can take it like this. We were doing it like this: a comma b is related to R. So a is one element and b is one element. So this can be written as a comma b and c comma d belongs to R, like this. So these two means the same thing. Just a simple thing is here a is replaced by a comma b. Only this. Okay. So this can be written. These two are equivalent, and you can write it like this. So let a comma b is related to c comma d, and what this implies, if they are related, then it can be written as like this: ad is equals to bc, like a plus d. Now so if a comma b is related to c comma d, then we have to prove that, so this is where we have to prove that c comma d is related to a comma b. That is what we have to prove, and in order to prove this, we have to check whether these are equal or not. Okay, what we have to do, this: cb a plus d is equals to ad b plus c. Okay, so in order to prove this, you have to prove this. If by the help of this you can get this, then this implies that they are related to each other. Okay, so what I can do, I will just rearrange them. Okay, so I am just going to rearrange this. So after this, I can write it like this: bc, like a plus d is equals to ad b plus c. So cb, just rearrange this, and this can be written as a plus b and ad b plus c. Right. Okay. So ad is going to this is this. Okay. So now these two are equal. So this implies that c comma d is related to a comma b. Hence R is R is symmetric. Got it? So this is how you have to do this. Hence R is symmetric. Now third one is transitive. So transitive is important. I already told this. This question is asked in 4 marks. These two are of 1 marks, and the transitive part is always going to be of 2 marks. Okay, so it will be little bit lengthy. So that is why I am going to rub it. So you please note it down. So next we have to prove that it is transitive also. We have already done with symmetric and reflexiveness. Next is transitive. The third part is transitive. So in order to prove transitive, let a comma b is related to c comma d. Then this implies that a d b plus c is equals to bc a plus d. Okay, so this implies this. Now also let c comma d is related to e comma f. Now this implies that cf bracket d plus e is equals to de and c plus f. Okay, so this is equation number 1 and this is equation number 2. Okay. Okay, so what you can do, well, it is something like this: a comma b, this can be written as let's say this is x, let's say this is y. So x comma y related to r, and here it can be written as y, and it will be written as z. So y comma z related to r, and we have to prove that using these two. We have to prove this x comma z related to r. So this is just for your understanding purpose, how you are going to, how you are doing this, right? So this is just in place of x, this is just place of y. Okay, so I have to prove x comma z. So in short, I have to prove that a comma b is related to e comma f, and in order to do so, I have to prove that a f b plus e is equals to be a plus f. I have to prove this. So using first equation first and second, I have to prove this. If I'm going to do this, then obviously this is related to this. Okay, so from equation 1, I'm going to take equation 1, AD b plus c is equals to bc a plus d. Okay, so this can be written as b plus c upon bc is equals to a plus d upon ad. So what does it mean? 1 upon c plus 1 upon b is equals to 1 upon a plus 1 upon b. Let's say this is capital A. Okay, so this is equation 1. Now from equation 2, from equation 2, what I can do, I can write it like this: cf d plus e is equals to de minus c plus f. After cross multiplication, this can be written as 1 upon d upon 1 upon e is equals to 1 upon c plus 1 upon f. This is b. Now what you have to do is you have to eliminate c and d. Okay, so from this, if you add these two, 1 upon c will cancel out with 1 upon c, and 1 upon d will cancel out with 1 upon d. Okay, so c and d will be eliminated, and if c and d will be eliminated, the question with the solution will become easy. Okay, so this is a rough work. You have to do it in rough. Okay, now I'm gonna rub it. Now add equation a and b. So after that, this add equation a and b. If you're going to add this is going to be this 1 upon c plus 1 upon b plus 1 upon d plus 1 upon e is equals to 1 upon a plus 1 upon b plus 1 upon f plus 1 upon c, right? So this is cancel out with this is cancel out with this. Okay, so 1 upon b plus 1 upon e is equals to 1 upon a plus 1 upon f. Now just add them. This is going to be b plus e upon be. This is going to be f plus a upon af. Now cross multiplication, a b plus e is equals to bc a plus f. Okay, so that's it. So what this implies? This implies that a comma b is related to e comma f. Okay, hence r is transitive. So r is equivalence as well. So this is how you can do it, right? So this is a very important question, and I'm gonna show a lot of example on this, and this will assure a 4-mark question from your exam, in your board exam. Okay, so this is how you can do it.